Hey y'all, if you're seeing me or hearing my voice on this, that means I am heading to California, and I'm very excited. But I'll miss y'all, and I'm sure I'll have some stories to tell you when I get back. This is our TCAP prep for Thursday, April the 9th. That's right. Okay, so number 1. The Great Basin in Nevada is characterized by uplifted, tilted blocks forming mountain ranges and down-thrown blocks forming basins. What type of rock is most likely to form in the basins? Well, there's 2 ways you can look at this question. 1, you can remember that rocks and falling rocks and moving rocks make littler rocks sediment, because your right answer is sedimentary. That's one way to look at it. Or you could go process of elimination. There should be 2 words you automatically think of with metamorphic rock. They are heat and pressure. And there's nothing about heat and pressure there at all, so that's out. And igneous rocks come from one place. They came from cooling magma. Magma that's been shot out, extrusive, or magma that's cooled underground. Intrusive, so that makes igneous rocks. Those are both out because there's no magma. So sedimentary is your only choice. I hope you picked B. Number 2, decayed prehistoric plants have helped in the formation of. Hopefully you're going straight toward fossil fuels. Hopefully you're going straight for coal and the like. And each of these will have choices that are right, but you have to have the one that has all 3 that are right. Coal, oil, and gas, for sure, are all good possibilities. Coal, shale, and quartz. Shale's out because that's metamorphic. Quartz is out because that's a flipping mineral. Shale is out. Quartz is out. Shale is out. Granite is out. That's an intrusive igneous rock. The only one that has all fossil fuels is A. I'm getting text messages if you hear that. All right. So I hope you picked A for number 2. Number 3. Which property of a mineral can be determined by just looking at it? Well, if you're a superhero, you can do a lot of these. But if you're just a normal person, the only one that you can look at and see, hey, is it shiny or not, is luster. Mass requires a tool. Weight requires a tool. Hardness requires a scale. And you remember our little porcelain scratch plates that we practice with? Remember the inside of your lid of your toilet? Because you have some unglazed porcelain at your house. Anyway, luster is the one you can just look at. Number 4, which of these illustrates that sound can travel through 2 different types of media? Media just means particles, means stuff. Talking to someone underwater in a pool, that's just one media, water. Oh, it's thundering, I hope you can hear it. Hearing a loud whisper from across the room, that's just one media, and it's asking for 2, that's just air. Hearing people talk on the other side of a wall. There's your 2 media. The wall is a solid, and the people inside are talking through air, so there's your 2. There's your 2. C is your best answer. I hope you picked it. Hearing thunder from a distant storm. How funny is that? It just thundered. Well, that's just cool. But that's not it, because that's just air. But still, I wish I had been reading that when it thundered. That would have been really cool. All right. Oh, that's cool. All right. When pressure, number 5. Spin on there. Oh, don't you miss me? Spin on my paper. All right. When pressure is released along a fault line, the energy produced spreads as mechanical waves in the form of an earthquake. Mechanical waves transferred to the air. Mechanical waves are longitudinal waves. If waves are transferred to the air, is it going to become sound, electricity, light, or heat? Well, I have cool news. It's sound. You can hear an earthquake. And if you've ever watched it on the movies, there's sound, but that's actually real because you can hear an earthquake. Number 6, when a compression wave, that's a sound wave, travels through a medium, in what direction is the medium displaced? If you remember when we did our slinky, when we pushed the particles of the slinky, we didn't shake it. When we just pushed it, the particles of the slinky were the pinch that you saw travel down the slinky went in the same direction as the push. You know what? Oh, look, I have her text. Sorry. I'm going to show you something. That's my Facebook. That's the one to see it. Compression. Don't go to compression stockings. Waves. Particles. Particles. Let's see if I can find you a little. That's what I wanted. I wanted a little GIF. Let's see if it'll load. Yeah. Hope you can see it. So when you push a particle, when you push a wave this way, if you notice all the particles, they're just going in the same direction as the wave. Let's see if I can go again for you. I'll try and post that for y'all. Wish I didn't have, there you go. The energy is pushing the particles and they're going in the same direction. When you push the particle for a transverse wave, you have to shake it up and down and the wave travels this way. Remember, that's perpendicular, but this is parallel. It goes in the same direction. All right, so it goes in the same direction. Let's see. All right, that's it. Good job. See ya.